It's a pleasure to be here. I'm Martin, and yeah, I'll start with a few words about myself and about my history with Scala. Um, I first learned about Scala during my bachelor in an object-oriented programming course, and I really liked it. And so ever since then, it was kind of my favorite language. And yeah, as Christina already mentioned, I was lucky enough to actually do my master's thesis with Martin Odersky. And then I started working as a Scala engineer at Ematic, which is a small Prague-based trading company. So yeah, I really enjoy playing with advanced features in Scala and the new features that are coming up. And I also quite enjoy working with databases. Um, and I like to do different experiments. And so this talk is about an experiment that I did recently with Scala and macros and databases. So the idea was, what if we ran SQL queries in a macro at compile time to get back a type-checked result? Um, yeah, it was just some fun thing that I wanted to make. And I started coding, and basically when I saw the result, I thought it was really cool, and I needed very little code to do something interesting. So I thought I would share it here. And on top of that, I also used names tuples, which is also quite cool. So maybe I'll start by saying a few words about names tuples because this is something very new, and I guess many of you might not have heard about them yet. Um, it's a new feature in Scala which lets you basically assign names to elements in a tuple. So like here in this example, we have value person, which is a tuple with two fields, and the first one we call it name, and the second one we call it age. And then instead of the regular tuple syntax where we would access it by _1 and _2, here we can access it with the names that we assign to those fields, so name and age. So I think that's really nice. It makes your code much more readable. Uh, it's not actually part of Scala yet. So in 3.5, if you want to use it, you have to import this Scala language experimental names tuples. So the experimental keywords is basically a warning that you shouldn't use it because it could still change or even be removed completely. But as of now, we already know that in Scala 3.6, it should most likely be present, not experimental anymore, but just a normal part of the language. So I was so excited about them that I've already started using them in some personal fun projects, and we'll also see them used in today's talk. Um, Besides that, I will be showing some code. So if you want to, you can scan this QR code to get to a GitHub repository where you'll see all of the code. I'll also show the QR code later in the last slide and maybe share it in the Discord group if you don't get it right now. Um, but yeah, now let's get to the interesting stuff. And so the first question that I should answer is like why would we even want to run these SQL queries at compile time? Like, does it make any sense, or is it just mm, a fun thing to do? So I have this example, like motivational use case. So let's say that we're running an online bookshop, and let's say that among others, we're selling a textbook about functional programming in Scala. And the textbook recently got a second edition where we added some more chapters, and we actually made a mistake. And in one of the chapters, we happened to use futures instead of monadic effects. And that's horrible, right? So our boss is furious. Look at what he looks like, or at least what ChatGPT imagines him to look like. Uh, and he wants us to do something about it. So of course we have to fix it, make a new edition where this mistake is repaired. But also he wants us to send an email with an apology to all the user who bought the book since the second edition was released, and to give them a free voucher. So okay, how would we solve this problem? Well, I guess what I would do is first open up my favorite SQL tool and run some query to get information about all the users that were affected. So yeah, I would write this query and then maybe export it as a CSV, load the CSV with Scala, and then go over the result row by row, and for each row generate a voucher, send it to the user. And that works, but it's not super pretty. It's not super fun. It's not super safe because reading the CSV, it has its issues, right? I have to know the ordering of the columns, or I have to know their names. I have to somehow be able to access the columns in a not type safe way. And I would like to avoid this. I would like to just run the query directly in Scala. And of course, I could kind of do that uh, even with existing SQL libraries. Uh, but I would still have to keep looking into this SQL tool to actually know the names of the columns. Then I would have to convert the types, right? Because I would have, or I would have to somehow define what the types are. And with this experiment that I did, I actually ended up getting a solution that looks something like this. Uh, so here you see I have some function which is called database.query, and it gets the SQL query as a plain text string. And then it executes the query, and it gives me back some iterator of rows. And for each of the rows, you can see that VS Code is actually telling me the names of the columns that are there, and it's giving me the correct types. So that's quite cool. And this row actually, the type of the row is the name tuple that I showed you before. Um, so I was really surprised by how quite easy it was to implement this. And I will show you in this talk a bit about like what I did. Um, because the time constraint is quite strict, I won't explain everything in a lot of detail, but I hope to show you that really it's not too much code, that you can do something interesting with very little code in Scala. And yeah, so I hope to basically excite you a bit and show you something cool that I did. Um, so yeah, let's start by looking into the technical details. So this database.query function is actually a macro that does a few things. Uh, First, it will dry run the query at compile time. So by dry run, I mean it will just somehow talk to the database to get information about what the query returns. Then it will build the row type. So it will build the name tuple that represents the row. And then it will build a conversion function that takes the row from the database and creates an instance of this named tuple. And then finally, it will put all these things together to create like the body of this function. So that's the high level idea. And now we can look at the individual steps. So I'll start with the last step, actually, putting everything together, because that's probably the most intuitive one. So basically, you see that this is the query function. It takes the query as a string. Then it takes some connection. So this is the connection from the vanilla Java SQL library. And then, of course, it executes the query. So this is how we execute the query in Java SQL, right? Just create a statement, and then on the statement called execute query. This gives us back some result set, which is from the Java API, so it's not very pretty. So actually ended up creating this result iterator, which is just something that implements the iterator interface. And it's like a facade that hides away the Java result set. And it also takes a conversion, which is the function that I mentioned before that converts the row to the named tuple. So now what remains is basically the conversion function, so these three question marks. And in order to do that, we have to cover the first three steps. So the first step, the dry running of the query. So we need to somehow get information about the result from the database. What I did is I created a temporary view, And then I pasted in the user written query, and I wrapped it with select star from the user defined query and limit 0. By this, I'm hoping to tell to the database that it shouldn't do any expensive computations. Like if the query returns a million rows, I'm not really interested in the rows. The only thing that I'm interested is to have this temporary view which has no rows, but it has all the columns that this original query has. So once this temporary view is created, I can get information about this. So I was working with PostgreSQL, so different databases might have a slightly different way to do it. But in PostgreSQL, I get the information from the information schema. So I run this query, which gives me a list of columns. So for each of the column, I get its name and I get its data type. And once I have this information, I can drop the view again. And that's all that I need in order to construct the named tuples. All right, so that's the dry run of the query, and this will happen at compile time. And once we have this, we have to really get into the macro stuff. And I decided not to put this in the slides because it would be quite cumbersome. Instead, I will show you the code directly. So uh, I hope this is readable enough. Maybe I'll make it slightly bigger. Uh, yeah. If it's still too small, please let me know. Uh, Here is the query function that we saw before. Looks good, perfect. It has the same signature, but a few things are different. So firstly, the body is missing, right? Instead of the body, there is this code, which is basically the macro invocation. And then there are two extra keywords that we didn't see on the slide, transparent and inline. So the inline, it's basically it's necessary in order to invoke a macro. The function needs to be an inline function. And the transparent keyword tells the Scala compiler that the result type of this function will be something more specific than what's written here. So it will actually not be iterator of question mark, but it will be iterator of the named tuple that I construct within the macro. So the compiler will look at the type of the query implementation, and it will propagate the type back into here, and then from here into wherever I'm calling this function from. And if we look at the query implementation, we see that it contains the 4 steps that I mentioned before, right? So the first one is to dry run the query to get the information about the columns names and their types. Then I construct the result type, so the names tuple. Then I construct the conversion function from the result set to a tuple. And finally, I put all these things back together. So let's briefly look into each of these steps. First, the dry run. You see here, this is exactly the SQL that I showed you before. And below that comes something that's slightly surprising and not very pretty. So I'm starting an external process, PSQL. I'm giving it the query to run it, and then I parse out the standard outputs to get back the information about the columns. The reason why I'm doing that is because there's a bug in Metals, which causes me not to be able to use Java SQL directly in the macro. It somehow sets up the class path incorrectly, and then it doesn't find the driver. This is really a problem in Metals. If I run it with the compiler, then everything works perfectly, but Metals somehow has this problem with the class path. Now, the nice thing is, this issue has actually been fixed earlier this week, I think on Tuesday. So with the next release of Metals, I can remove this weird hacky thing and instead just run Java SQL directly in the macro. So then this will become slightly prettier. But for the user, or if we go outside this dry run function, then you can't really see it anymore. So yeah, let's pretend that it's not there. And once we have the result of the query, so we have the information about the columns, we can construct the name tuple. So this is probably the most complicated part about this whole code. So I will not explain it quite in detail, but just on the high level, I want to mention what the compiler sees actually when we say named tuple. So the compiler represents the named tuple. So at compile time, it's as basically a pair of the names and the types. So uh, so this is how it knows how we can access the individual elements. At runtime, it will actually be just a regular tuple. And so to construct this type representation of the names tuple, we have to construct type representations of the names as singleton type strings, and then and then another tuple of the element types. This is exactly what we do up here. Again, it's a bit technical to explain like the nuances here, but the high level idea should be even readable if you've never worked with macros. So we have the columns, which are actually named tuples as well. So they have names and DB types, and we fold over them. We start with a type representation of an empty tuple, and then for each column, we get the name of the column. Then we convert this into the type representation, and then we create a type representation of the like accumulated tuple, and we add to it this new name. This is how we construct the tuple of the names, and then similarly we do it with the types as well. So again, we fold over the columns, but this time we look at not the name of the column, but the type as it was returned by the database. Then we do some conversion to a Scala type. So this is really just a match on the string. So for example, if PostgreSQL said that the column is of type text, or if it says that it's of type character varying, then I will say that my Scala type is the type representation of string. And similarly for integer, and so on and so forth. Yeah, and then once I have the names and the types, I just put them together to create a name tuple. So now I have a named tuple type, and all I need to do is construct this conversion function. So it goes from a result set to a tuple, and the way it does it is it calls get object. So this is from the Java API of the result set. It gets the name of the column, and I do this for all the columns and construct a tuple out of it. This is as I said before, in runtime, actually the names of the named tuples are like not there anymore. So it's fine that I'm just generating a tuple as a value here instead of the named tuple. And I will do some ugly typecast later. Actually, I will do it right now. So here is the last step of putting everything together. We've seen most of this code before in the slides. So the first two lines we saw, and then the last line we saw. But here, instead of the three question marks that we had before, we have this make row, which is a function that calls the result set to tuple, which gives us a tuple, and then we have to cast it to the name tuple. So the T here is the result type here, which is the result type that we built, so the names tuple. This is the entirety of the macro, and we have a few more minutes left. So now I will show you how it works. This is a code similar to the screenshot at the beginning. So here I'm running the query, and you can see that the type of the row is a named tuple, which has all the fields that the result has. Let's see what happens if I change the query. So for example, I can delete this join completely. So I will just have select star from purchases. That means I will lose some rows. And let's hope now that things don't break. No, they didn't. If I hover over the row now, you can see that there are less fields. And I'm even getting this bug highlighted by VS Code because now row.name and row.email doesn't exist because I didn't join on the customers. If I put the join back in, I get the bug goes away. I could also do some more custom selects. So maybe if I select just purchase date, I call it something different, and maybe name I also call something different. Then again it gets reflected, and I also get auto completion. So here I have the N and I have the PD. Yeah, and that's it. So if we go back to the slides, I will give little checkboxes here because I didn't explain entirely how the macros work. I think if you haven't seen macros, it might have been a little confusing, but the main thing is it works. Our boss is now happy. And I hope I managed to show you at least that it's really possible to do very cool stuff in Scala with very little code. And if you're interested in how exactly it works, you can scan this QR code and check the code, maybe read it more slowly. I tried to add quite a few comments to explain what's happening in there. And also, if you have any questions, feel free to let me know and I can try to explain or send you some resources. And also, I hope you enjoyed the name tuples because personally, I think they're super cool. And I would be curious to know if you think you could use this in practice. And if you would, let me know. Maybe I could publish it as a library and add some more support because you saw for now I only support like 3 data types. So maybe add some more of that and yeah, make it more production ready. Uh, with that, thank you very much for listening.